Think about clipping. What's clipping? Clipping means it is the removing of some positive or negative side of a waveform. What's clipping? It's removing positive or negative side of waveforms. Okay, now we want to design a clipper circuit that has to remove the positive cycle above the VD level. VD means it's a diode above the diode voltage level. We have to get the waveforms like this. So this is my ongoing waveforms. This is the VD level. Then after this we should not get the waves, and the negative waveforms has to be done as it is. Let's design that. You will get clarify when we design it. So we want one source for that. Okay, one source and one resistor and one diode D1N4002. Okay, so for clipping there are basically two types. One is the positive clipping, negative clipping, and another one is that's the mixed clipping. That means both positive and the negative side all are clipped. So to design positive clipper circuit means positive clipping. That means we are removing a positive side of a waveform, a part of a positive side of the waveform. We need to place the diode in this manner. That means this is negative. Okay, for a positive clipper, remember this, to remove the positive waveforms we need to keep the diode in this form. That means this diode has to be in this form. Remember this diode has to be in this forms. Okay, negative downside. Then yeah, we will connect all these things. Okay, and here from here to here. Then one ground. One ground I will connect, and I will give some this is 0, and let's say amplitude be 10 volt, and here frequency it has to be 1 kilohertz. It has to be more. So this is also a hardware experiment. While designing in the hardware, we need to use a function generator for creating the waveforms of our required waveforms. That means here we need to set the frequency for that waveforms and amplitude and all. No, so for that we are using function generator. This function generator looks like this. Just observe here. This is a function generator. Here there is a range, and here something hertz is there. This is a total range of 2 megahertz. That means we can produce the waveforms of frequency till 2 megahertz. So here there are some buttons, that is the range. That means 1 kilohertz, 10 kilohertz, 100 kilohertz, like that. So if you want 1 kilohertz, then we need to press that 1 kilohertz button, and here is something called frequency and fine adjustment. These two knobs will be there. You need to just change the frequency, and you have to see in this picture as in this screen as 1 kilohertz. Here is a hertz and kilohertz indicators will be there, and you need to look at those things. And output, here is the output. Initially we need to connect this function generator to the CRO. CRO means in order to observe the waveforms we have to connect this to the CRO. And in CRO we need to see how much is the amplitude. Frequency anyway we are setting here. we need to set the amplitude now. For example, that 10 volt, that's given as 10 volt. So how to set this amplitude? We need to connect this function generator to that CRO. The CRO is like this, okay? And here there are two knobs, that's the voltage per division and time per division. So we need to set the voltage per division knob, for example 2 voltage per division. Okay, I am setting that knob to 2 voltage per division. Then in CRO waveform, we need to observe one division is 2 volt. That means for 10 volt we need to keep, that's 10 volt peak to peak means above 5 volt, below 5 volt. For 2 volt one division means 2.5 lines. That wave have to cover 2.5 lines. 2.5 lines above, 2.5 lines below. So totally 5 lines. 5 lines means 5 into 2 volt per division, 10 volt. 10 volt peak to peak. We just need to change that amplitude in the function generator here so that those waveforms will change in that amplitude. Then okay, this is just a hardware part. We need to set the required frequency and the voltage. Then let's come back to the circuit. Okay, here just we designed 10 volt and 1 kilohertz. Okay, then if we design like this will going to give the waveforms, the positive waveforms above the VD level will be clipped out and the below is same as it is. Let's see its output. Okay, we need to keep probes. I will keep the probes. We need to see the voltage across this diode, okay, not across the resistor. Remember this. We need to see the voltage across the diode because these 2 points are our outputs. These points and these points. These 2 points are our outputs. Let's keep this. Yeah. Then, yeah, we can see that this is a 0.7 volt. I guess it's a point, yeah, it's somewhat 684.84 millivolt, nearly equals to 0.7 volt. So the above peak after this 0.7 volt will be cutted and the negative peaks they are as it is. How it works means during the positive half cycle the diode is there, no, this diode until it reaches the 0.7 voltage it will not conduct because the diode needs minimum of 0.7 voltage to conduct across it. So until 0.7 voltage we will get the positive waveform, but after that this diode will conduct. So the voltage across a closed path, if we see the voltage across any closed wire, that is 0. So we are not getting any waveform after the 0.7 volt. During the negative cycle this diode won't conduct. So if we measure the voltage across the diode, then we will get same as the input voltage. This is called as the positive clipper. Now we need to clip some voltage. If we want to clip the voltage, positive voltage with some reference voltage, that means we need to clip the voltage after 2.7 volt. So here it's a 5 volt and no, here it's 10 volt and amplitude means we have 10 volt and here it's 10 volt, no. So we need to clip the voltage after the 2.7 volt, means 0.7 voltage is already dropped in this diode. So 0.7 plus 2, so we need to add 2 volt. that we need to add the DC voltage. Okay, VDC